Hey guys, welcome back to another video. So today we are going to learn about data modeling, how exactly data modeling works, what is it all about, and I'm going to cover some of the fundamental concepts of data modeling. So these are going to be some essentials and also some intermediate level concepts. So in essentials, we've got database schema, server configurations and documentation. So in database schema, we are going to learn what are all the different things that you need to take care of when creating a schema. So these are going to be things like nomenclature and what are actual schemas, and also the normalization forms. These three are pretty much essential. When I say essential, these are the base vanilla versions of the concepts that you have to be familiar with when you're creating a database. Okay, so first take let's take a look at nomenclature. So SQL follows a very simple nomenclature. So no matter which database you look at, until and unless it is made by some amateur, SQL databases always follow camel case. So there are two different types of camel cases, by the way. If I have to, let's go here. Let me create a new text file. Select SQL. Okay. So if I'm creating a database table, let's say, or even a database instead of a server, then I'll have to give some kind of name for that database, right? Now, for this example, let's take uh, employees, employee DB. Okay, or yeah, let's go with employee DB. Okay, now employee DB, let me pick a different name for this. Uh, okay, how does this look? Well, if you see what I've done here, I'm starting every single word's first letter with a capital letter, which is called camel case. We all know that. But if you ask a JavaScript developer to write something in camel case, they won't write it like this. They will write it like this. Okay, so there is a small difference here. Usually some of the other domains apart from SQL follow the second nomenclature where they don't start the very first letter of the first word with a capital letter. They start capitalizing the first letter from the second word. Okay, so that's not something that we follow in SQL. We usually maintain first letter as capital for every single word. Now that is a simple nomenclature. Again, some people usually do prefer to mix it up with snake case as well. So things like company underscore, name underscore. So some people like to do this, but this is not at all a professional way of creating a database. Okay, so this is a normal way of creating a database. Now when it comes to nomenclature, we have to follow the same nomenclature across the database. Okay, so if you are using any kind of short forms, for example, if I want to say CN for my company name, then I have to follow the exact same uh, short form across my DB, irrespective of it being a table, column name, or even a store procedure name, whatever that may be. You have to follow the same nomenclature across the database. Okay, so that's a short introduction for nomenclature. It plays a very important role in terms of signifying your capabilities and your uh, professionalism. That's nomenclature. Now let's go back to the slide. Oops, just a peek there. Yeah. Now the second thing is going to be schemas. Now whenever you're creating a database, okay, it's going to be just one single database. Now within that database, if you want to divide your tables into two different segments. Okay, so let's say you have created a table and you want sorry, you have created a database and you want to have 20 different tables for the sales department and 20 different tables for data science department. Okay, if that is the case, and let's say the sales department wants to create a table called uh, ABCD. Okay, let's go with an example, ABCD. And even the data science department wants to create a table with the table name of ABCD. Now, since both of these tables are in the same database, it's going to create a problem, right? You can't create two different tables with the same name. Now, this is where schemas will come in handy. And not only this, but there are a lot more advantages to schemas. So you can create separate schemas inside of a database. Now let's say if I create a schema called uh, SLS for sales department, or SLD for sales department, and DSD for data science department. Okay, now these are my schemas. The moment I create a schema, I can create two different tables with the same table name as long as they are in the different schema. Now this gives me an advantage. Now both of my departments are satisfied with the table name, and also if I want to use both of these tables in a single query, I can still do them. Okay, because the schemas are different. So as long as I'm in the same database, as long as I have two different schemas, I can use the same table name. Oops, yeah. So this is an advantage. This is one of the biggest advantage of using schemas. Again, there are so many other minor advantages to using schemas as well. You can modify some properties of a particular schema, and that they are going to reflect for all of your tables. You can change security related policies as well. So there are a lot more advantages to using schemas, but for intermediate level, the biggest reason why we implement a schema is when you want to have same table name. And also, let's say if you've got all 40 tables in the same database, it becomes very difficult task to identify which table belongs to which department. But the moment you see a schema here at the prefix, then you know that this table belongs to this department. Okay, so all of these tables, so let's assume that these are all different table names. Now I can easily say, just by looking, that all these tables belong to DSD department or data science department. Okay, so that's the second most biggest advantage of using a database schema. Okay, so that is about schema. And then we have normalization forms. So this is a very very important concept. Now when it comes to normalization forms in SQL, oops, let me go here. Great. There are concepts called 1NF, 2NF and 3NF. Okay, so first normalization form, second normalization form, and third normalization form. Now what exactly are these normalization forms? When you take a table and when you split it into two different tables, like you see here. Okay, so here we've got uh, two different tables, sorry, one single table which has been split into multiple tables. They've made a mistake here. This should be called one. Okay, let's take a different table. Come on. Yeah, this looks good. Okay, so this is the first normalization form where you're not doing any kind of splitting. Okay, all of your data is sitting inside of just one single table. Okay, Now, there is a huge disadvantage to this, and there is just one small advantage to this. But uh, if you weigh the pros and cons, the cons are way bigger compared to the pros. So, the biggest disadvantage here is you are going to store a lot of duplicate data. So let's say if you are keeping track of employees login and logout timings, okay, then you will have let's say 90 or 20, 21 different columns, and one of the column stores the data about login time and logout time. And maybe if the employee takes breaks in between, maybe you're storing that as well. Now every time you enter a record for every login and logout, you have to fill in the data for the rest of the fields as well. You can't leave them blank, right? You have to fill in the employee ID, name of the employee, what is their current CTC, who are their reporting managers, what is their domain, what is their department, what is their profile, what is their title. All these kind of details have to be filled in for every single one of those records. So this takes away a lot of storage space. Plus, whenever you're doing any kind of a query, it takes hell of a lot time to retrieve the data that you want. So we divide the tables, we split them into multiple tables. The moment you split it into, the moment you split one table into two different tables, let's say for the same example, I can store all of the employee details, all of the static details which won't change very regularly. I'll store all of them in a single table, and I'll maintain a separate table wherein I'm storing only the employee ID, login time, logout time, and also if the employee takes any breaks, at what time did that employee take a break. Only these kind of things. Now when I do this, the only column that I have to fill in additionally is employee ID, which is mandatory, and I can deal with it. It's pretty much necessary to store the employee ID, right? Now this is second normalization form. If I split this furthermore, then it's third normalization form, fourth normalization form. The more number of times you split it, the more the n value gets. Okay, so that is normalization form. When you create a database, you have to make sure that every single table has columns which are going to be unique to that table, and the data that you're going to enter into these columns is not going to be duplicated ever. Okay, so you need to make sure that your database is well thought out and all of your tables are well normalized. Okay, so those are normalization forms. So after normalization forms, we've got schema configurations, server configurations, I'm sorry. So whenever we are creating a database, your SQL is going to have a master database. So let's take an example of Azure SQL. Okay, now let's say if you've created a database, then by default, if you have created a server, then by default SQL is going to give you a database called master database. Okay, so this is like a system database, the default one. Now this is not something that you would ever use to store your data, because this is neither secure nor configured properly, and also it's just one database. Now all of your tables can't be sitting inside of this one database, right? So whenever we are creating a database, we have to uh, create the database in the SQL server, not inside of the master database. So usually what happens is we can create database instead of master database. There is a possibility. It's not that hard actually. So you can just write a create database query, and then you can run it by selecting the master DB, and it will create a database inside of master DB. So this is kind of a simple mistake that a lot of people do. So whenever you create a server, let's say if you're using Azure, now you can go to the Azure portal, you can create a server, but after creating the server, you need to create a database separately. You can't connect to the server and then create a database from there. If you do that, this is going to create the database instead of master DB. Unless of course you're using unless you're using SSMS. So SSMS does allow you to create new database instead of a server. Now, what is a serverless DB? Before we go there, MasterDB, there is one more thing about MasterDB. So you can use MasterDB to run queries to retrieve data about the database. So if you want to find out metadata about the database, or if you want to find out what are the different databases available in the server, and if you want to list out the different schemas that are available in this server, in this database, then you can go ahead and use the master database. Okay, so next thing is serverless DB. Whenever you're creating a database, let me show you that in Azure portal directly. So here I am in Azure portal, and let's go into SQL Server. Let me select my subscription. Okay, so here I've got a server existing already. So the name of the server is company name. Now this is my server address. I'll copy this. Now I can go ahead and create a database with the help of this server. To do that, I'll have to choose, not this, yeah, SQL databases. Let's go and create a database. Let me give okay, I'll use company name employee DB, and here you can see the pricing of this database, which is going to be this much of amount, which is very low. But right now this is instead of a serverless database, and if I go to configure database, this is where you can configure all of the different parameters that you want, and you can make your DB very much customized here. Okay, now server tier. The moment I go into provisioned, you can see how high the cost is. Okay, so this is something that you need to be very careful about whenever you're creating a database. So I always suggest you to take a deep look at what exactly are your requirements and what are the options that are available here, and then tally them properly, and only then create a database. Let's click on apply, review, and create. Okay, while it creates, let's go back to the slides. So that was about serverless DB. Let me select a pointer. Yeah, about serverless DB. Now next thing is authentication. Now where do we get authentication? When it comes to SQL, there are two different types of authentication that you can use. One is Microsoft Entra ID, and the other is going to be SQL login. Let me show you where we can get these two. Deployment is in progress. Meanwhile, if I go into SQL servers, this is a server that I've already created, but let me try and create a new one. I'm not going to create it, I just want to show the setting. There you go. Under authentication method, you've got three different options. Be very careful when you are selecting any one of these options. Let's say if you want to allow any one person to have access to the database server, sorry, not to the database, but to the whole server itself, then you will select Microsoft Entra only authentication, which means you'll have to select an admin. So this is going to be any one email ID present in your ADF. Okay, so let's say if you want to create a server and give access only to your manager, then you can go ahead and use this one. If you select SQL authentication, you can create your own username and password And okay, you can select your own username and password, and then you can use those details to log in into that database. uh, these can be shared with anybody, and whoever has the proper credentials along, I mean, when I say credentials, we need server name, this username and this password. As long as you've got three of these, you're good to go, you can log in. So if you're planning to share the credentials with a lot of people in your company, then you can go ahead and use SQL authentication. And if you want to do both of them, then you can select this option. Okay, pretty simple. So be very careful on selecting which kind of security authentication you want for your server. Okay, let's cancel this. Oh, by the way, let's see if the database got created. There you go, it has been created, and it is now associated with my server. So I should see all of the my details here. Yeah, there you go. So I've got my server name here, and I also know the username and password that I've set while creating this server. So let's go ahead and try and connect to this database today. Before we go there, let's finish up this thing. Okay, I hope you guys understood what exactly is authentication. Okay, so you can select SQL login or enter ID. Now, these are some of the intermediate concepts which will make you, stand out compared to the rest of the competition. Now let's go through them one by one. First one is going to be key constraints. Key constraints is pretty simple. So let's say if you've got two different tables, you can establish a relation between both of these, saying this is the main table and this is a related table, and you'll have one common column in both of these tables which you can use to map both of these tables. So let's go into Google Images, and if I type key constraints in database management system, there you go. This is a really simple example. So here you've got primary key and foreign key concepts. So if you see here properly, you've got roll number, name, course ID, and you've got a separate table which stores the course ID and the GPA associated with it. Okay, now I've got three students here, but let's say if I've got 3,000 students, they might have, every single student will have their own course ID. But if I go into this table, I've got only three records here, because even though there are 3,000 students, each one of them will get some kind of a course ID among these three, nothing beyond them. So it becomes easy for me to manage my GPA here. Let's say if I want to modify GPA in the future, maybe if I want to change 101 course ID to a GPA of 3.5, I can simply change it here, and whenever I need it, I can do a join and I can retrieve and I can find out if Prince has a GPA of 2 or 2.5 or 3.5 or anything. I can do any number of queries like that. So this is going to take out a lot of redundancy. So here you can understand the concept of normalization once again. So when I'm splitting that data into two different tables here, I'm maintaining a relationship between these two with the help of my primary key and foreign key table columns. Here, if you see, the student details is the table name, where course ID is the primary key, uh, and student marks is the foreign key. Okay. No, actually, I'm sorry, my bad. This should be the other way around. Student marks is the primary key, and student details is the foreign key. They have got it reverse here actually. Uh, Prepinsta, come on. So if you see the student marks table, this is a primary key column. Primary key itself indicates that there are going to be zero duplicates. Okay, so 101 is not going to repeat ever again. Okay, and all the values in this column are going to be unique, no duplicates, no null values. That makes this column as a primary key. Now I'm using this key reference in this table, which makes this as my foreign key. Okay, so the course ID in student details table is a foreign key. The course ID in student marks table is a primary key. That's how I'm mapping the relation between these two tables. So this is the concept of key constraints. Now when it comes to key constraints, there is one more advantage. Uh, so let's say you have a scenario where you want to delete every single record which has a course ID of 101. When you have that kind of a requirement, you can simply create a constraint rule where it's called as cascade actually. So let's say once you implement that rule, if you delete the primary key here, it's going to drop every single row whichever has its reference. So I've got 101 here for RN. So this record is going to be deleted. This one single row will be deleted from my student details table automatically. I don't have to go to that table manually. So let's say if you have employee database with 20 different tables, and all the 19 tables are referring to one table which has primary key of employee ID, then you can simply drop a particular employee ID, and that is going to reflect across the 19 tables. So imagine dropping every single one of them manually from 19 different tables. That's way more hard compared to just dropping it directly on the primary key. But again, there is a downside to this as well. So if you drop something by mistake, that data is gone, completely gone. So you can't undo this action. So we have to be very careful whenever we are using such kind of cascading rules on key constraints. So it's easy to create these relationships, but it's not that easy to determine whether you want to have such kind of cascading rules or not. So we have to do them at our own risk. Okay, so that is the concept of key constraints. Next is GUID. Let's go ahead and understand what is a GUID. GUID stands for Global Unique Identifier. And this is how it looks like. Okay. So in SQL Server or in other SQL databases as well, whenever you are defining the data type of a column, you have an option to choose unique identifier. Okay, so unique identifier is a kind of a data type which indicates my database to automatically create a value and insert into it. So whenever I'm inserting data to any of the other rows, I don't have to insert value into this column. So if I take the same example here, I've got two different columns here. One is X, one is GUID. Okay, so let's say the GUID column has been configured as unique identifier data type. Then if I do an insert statement and if I insert any data into column X, automatically a value is going to pop up inside of the GUID column. Now what is this value? Where am I getting this value from? GUID stands for Global Unique Identifier, which means this identifier, this value is going to be unique globally. When I say globally, across the database. So the moment this value has been generated, it's not going to be generated ever again across the DB. Irrespective of schema, irrespective of table, you will never find another GUID column containing this value. Now there is an advantage and disadvantage to this. Disadvantage being the pattern itself. It's such a huge number with a lot of different values, which is hard to understand. There isn't any particular pattern. Well, there is a pattern, but to the visual, to the naked eye, you can't really understand what exactly is the pattern, how has this been formed. But the important thing is This is going to be unique and it's going not going to repeat across the database. What is the you know what's stopping us from using GUID everywhere? Well, let's take employee ID again. Now, employee ID is a primary key, right? It's going to be referenced across 19 different tables. I know this. So, can I go ahead and use GUID for that? Well, technically I can, but we should not. Because even though it is generating something unique, the value that it is generating is not so simple. So, obviously, whenever an employee gets an ID assigned to them, that's going to be repeated, that's going to be used in lot of different places, in ID cards, reports, even documents, registers with security guards, lot of different places. Now you can't remember this huge number, right? It's very difficult to even keep a track of the first section of it. So for a column like employee ID, it makes much more sense to just go with serial number. But for for columns where you want to store some kind of a unique identifier in the backend side, and you know that you're not going to refer to this over and over again, in those kind of scenarios you can simply go ahead and use the concept of GUID. I'll give you a small example. So what are they using here? Okay, forget about this. Okay, so let's say if you have built an e-commerce website and you've got bunch of products with you, each product will have a product ID. This product ID will not be excuse me, this product ID will not be shown to the user. You are simply going to show the product title, product image, all those kind of details, but not the product ID. When you know that you are not going to use uh, the particular GUID value on screen, then you can simply use it behind the scenes with full form, without any hesitation. You can directly go ahead and implement GUID concept for this column called product ID. But for the employee ID column, it makes much more sense to just go with serial numbers. So that is the concept of GUID. Once we log in into the database, I'll show you how we can create or modify existing column into unique identifier, and also I'll show you once we get into the create schemas, I will show you how we can create a unique identifier column. That is the concept of GUID. And next we have something called SQL views and store procedures. Okay, so what are SQL views and what are stored procedures? Well, these are the two different concepts which a lot of people forget to teach whenever they're teaching SQL, or some people are not even aware that these two concepts exist. First, let's take a look at views. What are views? Well, view is simply, irrespective of SQL or a database, view in itself defines that this is just a view. This is not something that is actually present. This is just how you are viewing that particular entity. Now, when it comes to database or data modeling, view is basically how you are viewing this particular table. Now, let's say if I've got two different tables, I'll write a SQL query where I'm doing some left join or a right join, or let's take left join. Okay, I'm doing a left join on both of those tables, and I'm defining a where condition, and I'm doing some filtering, and then finally I've got my query ready, and I'm able to see some results with that query. I'll take this query and I'll create a view out of it. Now, every time my table changes, if I'm entering new data or if I'm modifying existing data, upsert operation, insert operation, so whatever changes I do, all those changes will be done onto my tables. But whenever I run the view, this is going to take a reference from those tables again, because in the backend, it's simply going to execute the same query. Now, when I say view, if I go back to this thing. Okay, so let's take an example where I've got table 1, table 2, and I've created a view, and the name of the view is oh sorry, Python habits. So name of the view is something like result view. Oh, by the way, whenever we are creating a view, we always use underscore vw as the suffix. Okay, so even though you are following camel case everywhere, whenever you are creating a view, try to use the underscore vw to indicate that this is a view. Now instead of this view, I've got some columns from some tables, left join on some other table, some where conditions. Okay, now I'll create a view based on this, wherein I'm using both of these tables. Okay, so once I create a view, I can simply write a query like select star from this view name. Okay, I can just simply run this one query and it's automatically going to execute this whole thing. So that is the concept of a view. Of course, I can always do a where condition here, order by, all those things as well. But basically the general idea is you don't have to write such long queries over and over again. You can simply store the query in a view and you can run that view whenever you want. Keep in mind, view is simply a query being executed in the backend. So whatever data that you see in the view is not some new table. So you can create n number of views. They are not going to take up any space at all. So even if your query gives you 9 million or 10 million records, you can save that as a view and it's not going to take even a kilobyte of space. Okay, so that is the concept of view. Next is stored procedure. Stored procedures are very much like functions. So in other OOPS languages you have functions, right? Similarly in SQL we've got functions which are called stored procedures. So just like any other function, you can call them to perform a repeated action, and you can write functions like take data from this table, do a left join on this, and then filter out on this condition, and whatever result you get, insert that result into this particular table. So all these operations can be written inside of a stored procedure, and you can also make use of variables, by the way, whenever you're creating a stored procedure. So you can write all of your steps inside of the stored procedure, and then calling a stored procedure, or a, you know how we call a function, right? Just write the name of the function. Similarly, whenever we want to call a particular stored procedure, it's basically exec stored procedure name. Whatever the name of your procedure is, you can just simply write that down here. You can simply write it here, and then it will run the procedure. Okay, as simple as that. Now when we get into the schemas part, I'll show you an example of how exactly the syntax looks like for a view and for a stored procedure. And next we have ER diagrams, entity relationships diagrams. Whenever you create a database, you want to visually represent everything in an image. That's when we go for ER diagrams in database management system. No, these are not ER diagrams. these are more like it. Okay, so this is kind of how an ER diagram looks like usually. So here you can see property, tenant, movie charges, unit. These are my tables. I've got 4 different tables inside of this database, and I'm mapping the relations between all these tables. Here you can see property ID is a primary key indicated by PK. Let me open this image in a new tab. Yeah, much better. So here you can see PK indicating primary key. Now every single table has to have a primary key. That is a mandatory thing whenever you're creating a database. Without a primary key, your table is just a blowed up version of a spreadsheet. Just a spreadsheet sitting inside of a SQL, nothing else. So you need to have a primary key for every single table. And again, depending upon the requirement of the table, depending upon the purpose of the table, you can create a foreign key. So here you can see property has property ID. This property ID is being used in unit and tenant table, and tenant has tenant ID, which is primary key, which is being used in movie charges as foreign key. If you take a look at the lines here, the yellow lines, they are indicating the relationship between these two tables. Now I can simply take a look at the column names here, and I can say that this property ID and this property ID are the same thing, but usually that might not be the case. So maybe I'm using some other name. I'll say P underscore ID or PR underscore ID to represent the same property ID. So it's not that obvious from those nomenclatures, but in this example, they have given the exact same name across the tables, which is a good practice, by the way. And once you have the same table, same column name everywhere, you can easily identify how exactly are they mapping with each other. So in SQL, we have 2 different types of mapping. 1:1 mapping and 1:many. We also call them as relationships, 1:1 and 1:many relationships. So this is a 1:many relationship. If you have a 1:1 relationship, it's kind of rare actually. If you have 1:1 relationship, then property ID is going to be unique in this table, and also it's going to be unique in my unit table. So even though this is a foreign key, there won't be any duplicates if it is a 1:1 relationship. But over here we've got 1:many relationship. From the symbol you can understand that. So in 1:many relationships, you know that this one value may be repeated many times in this table. The same thing goes with this as well. So this one tenant ID may be repeated multiple times in this table. Okay, as simple as that. So all of this is called as a entity relationship diagram. Again, there are no hard-bound rules as to how the appearance of this ER diagram should look like. So you have a flexibility to use any tool that you want. Trevor.io is a very famous tool which a lot of people use to create diagrams in a website. And SSMS gives you an option where you can create an ER diagram by default. You don't have to create it actually. The moment you connect to the server, it will automatically create the diagram for you. And here you can see how 1:many relationship looks like. These are actually the proper age-old OG icons for one and for many. Okay, so these are the concepts of ER diagrams. Yeah, if you see here, the user ID column, they're using the exact same column name here, but sometimes people create a database where multiple tables, even though they have the same key relationship, they will have a different column name. So in those kind of scenarios, it becomes really tough. So that's when you'll create the mapping directly onto the name of the column itself. So from this diagram, you can see that this table has been mapped with this table, but usually we draw the diagrams on a column level as well. So it becomes easy to understand that this one has many relationship with this column. So that is usually done on a column level. Let me try to see if I can find a good diagram for that. There we go, found it. So this is kind of how we do it. So for each column, we will indicate if that relationship is one to one or one to many. Okay, so that's the concept of ER diagram. Next is documentation. Now there are three different types of document which are mandatory whenever you are creating a database. Let's take a look at them. These are the three different important documents. This is a readme file because I'm maintaining all of the documents and the schemas in a Git repository, so I have to use a readme file. I'll show you that as well. But first let's focus on the documents here. So in order of importance, this is the most important document. So this is called as a data dictionary. We usually create a spreadsheet, and whenever you create a database, we try to create a data dictionary indicating all the different column names that are present. So here you can see, if I take a look at this, okay, here you can see entity is just another word that we use for tables, by the way. So this is the table that I'm referring to, and inside of this table, these are all the different columns I've got. Columns are referred with the word attribute. Okay, so these are the different column names and the data type of each column and the description of it. Okay, so once you have this data dictionary, you can easily recreate any table. So let's say if something got deleted by mistake, then you can recreate it simply. The same thing goes for every other table. So whenever you are solving some kind of competitive programming, you must have come across data dictionary. Like this or this or this. Oh, sorry, not this is the table directly. Yeah, or this. Yep. So whenever we are creating a data dictionary, we will store it in a spreadsheet format so that we can later refer to that, and also we can share it with anybody. Okay, so that is a data dictionary. Now coming to the second document, which is design document. This is the second most important one actually. Now in a design document, this is going to be a Word document. So obviously the first and the last page are going to be very important for you. They will act as cover pages. So if somebody tries to take a print of this document, this should act as a cover page. So on the very first page, we usually write down what is this document about, some information about the company, project name, database name, and the database version, along with who all have worked on this database. And then if you have any kind of additional note saying that this is for internal purpose only, do not share with anybody external, those kind of notes, just a disclaimer. So only these kind of information will be written on the cover page. If I scroll down, you'll find table of contents, and you can see that again, this is a documentation which you can modify as per your requirement. You can add more contents, you can remove some headings. It's all up to you. You can change the aesthetics, looks, and everything. but here I've written down some of the most necessary things. So these are going to be some different concepts which you might want to document for sure, because these are going to be referenced and used by whoever wants to get to know about the database. So things like what are the security measures that you have taken, and what is the procedure for backup or recovery if something goes south, or where can you find the data dictionary. If you have created one, then you can upload that to SharePoint and share the link in this document. And how exactly are you trying to implement the change management, what is the procedure that they have to follow if they want to do any changes to the database. All those kind of things, they can be written down here. Database requirements as well. So what are the different requirements that you need in order to use the database, connect to the database, those kind of things. Once you write down all of these, this is just some sample values I've just put in, some simple one-liners, but obviously when it comes to an actual database, each section will take at least around 2 to 3 pages. And at the very end, you've got amendment history. So this indicates what are all the different changes that this document has gone through. Okay. This amendment history only talks about the amendment history of this one particular document, only about the data design document, nothing about the database or anything else. But let's say if you have done some changes to the database, obviously we have to document them. So you'll come here and you'll change or you'll modify the document, and then you'll add your amendment here. Or if you found a mistake, or if you updated something in the database, you'll make the necessary changes in this document and you'll add it into the amendment history. Some people like to create this in the form of a table, but I really don't like to put table instead of a Word document. It becomes really messy to handle, so I just go with just spaces and tabs. Okay, that is about amendment history. And this is the database design document. Similarly, we have database schema document. Again, the same thing here, cover page. After the cover page, we've got table of content, and then I've got my amendment history. And just before the amendment history, we have different tables that are present inside of this database. Along with tables, you can also write down things about views, stored procedures, schemas, all those things. But do not store any SQL files here, okay? Any SQL syntaxes. This should talk only verbally. Everything should be just in plain English. Plain words, I would say. Okay, so these are the three different necessary documents. So they will fall under documentation. Now, apart from these three, you will have the actual code, actual syntax. Let me close this. Here in data modeling, in schemas, this is where I've got all of the schemas and all of the syntax for all of the code for creating my tables. So here you can see employees is primary key, SLS is the schema, salaries is a different table where salary ID is the primary key. Now here I'm setting a relationship. I'm saying that employee ID from this table is the foreign key, and it is referring to employees tables employee ID. Now what is DBO? DBO is the schema that I've used for creating this table. SLS is the schema that I'm using for salaries. So from DBO schema, take the employees table and take the employee ID column and mark it as the primary key for this foreign key. And here I'm saying on delete cascade. So if the primary key gets deleted, then you can go ahead and delete the related records from this table as well. So this is how you write the cascading rule. Similarly, I've got these two different tables, and the thing about DBO is this is a default schema. So SLS is a schema that I have created, but DBO is something that SQL gives you by default. Okay, so DBO is a default schema and you don't have to create that schema at all. So that's the reason why you will always see the table name given to you like this in SQL Server. So DBO, by the way, you can use the uh, square brackets whenever you are writing down any table name or a column name, by the way. So let's say if your column name is like this, then you can simply wrap it in square brackets, indicating that this whole thing is a column name. But of course, this is one of the worst way of writing any column name. So we usually go with camel case, where you don't have to use the square brackets. But let's say if for some reason you want to have space in your column name, then you can simply wrap it in a square bracket. And yeah, so DBO is the default schema given to you by SQL, and SLS is just the schema that I have created. You can give any name whenever you're creating a schema. This can be something like DFG or DFG or SGD or ABC or XYZ. It's completely up to you. Okay, now if I go down, this is a view. So this is the syntax that you can use to create a view. By the way, this is something that I'm not going to cover in today's session. This is how to create an index on a particular table, and also how to create a parameterized view. So similar to a function, you can create a view wherein you can pass parameters. So I'm not going to cover both of these concepts in today's video. I'll try to make another video covering advanced concepts where I'll cover both of these. But for now, this is how you can create a view. Create view, name of the view. Again, here I'm just indicating VIEW. I'm using the whole word, but if you're not comfortable using the whole word, and if your table name is already pretty long, you can always go with underscore VW. But since this is a very small table name, I'm going with a full word called VIEW. Now I'll say create view name as. The moment I put this on, whatever query I want to use for the view, I can just simply write it here. I can select this 4 lines, I can click on run, execute this, and it's automatically going to create a view with this name. Once a view has been created, I can simply say select star from this. Oh, by the way, always use capital letters. I know it doesn't matter much in SQL Server, but it's a good practice to always go with a capital letter. Okay, select start from view name. This is how you can create a stored procedure. Create procedure. Create view, create procedure. Just like how we use create table and all. This is the stored procedure name, and then these are all the different variables that I'm creating here as begin. So whatever I write inside of the as begin and end, whatever I've written here are the different steps that I want to perform whenever I call my store procedure. So I'll say declare this variable called employee ID. It should be an integer variable, and then insert into this particular table all these values. Okay, so whenever I'm calling this procedure, I have to pass in all of these values. So I'll insert all these values into this table, and I'm setting scope identity to this particular column, and then I'm also inserting the salary related data into the salaries table. By the way, if I don't give a schema, none of this is going to work. Okay, so I should be very careful whenever I'm referring to a table. I should be very careful, and I should pass in the schemas as well. Okay, so that is about a stored procedure. That is the syntax of a stored procedure, by the way. Okay, so I've got all of this code here, so I'll go ahead and create a database. I think database has already been created, so I'll just go ahead and connect to that database, and I'll execute all of this. Let's go back to the PPT. So after the documentation, there is one last thing left, which is Azure Data Studio. Now, lots and lots and lots of people prefer to use SSMS, SQL Server Management Studio, but there are so many other good tools that you can use to connect to a database. Visual Studio is one such simple tool where you can just download the SQL Server extension, and you can use it. It's very lightweight. You don't have to download a new app for that, and all of your good VS Code extensions can be used directly. So you can use VS Code as well. And Azure Data Studio is a tool very similar to VS Code. Okay, let's go ahead and explore that. Oh, seems like I'm already connected. Don't save it. Yeah. So I'm already connected to a database. No, I'm not. Let me delete this connection. I'll add a new connection. I want to connect to a SQL server, and I'll give the server name. Copy this, paste. Authentication type, SQL login. The database name, for now I want to have access to all the different databases present in there. None of these. Yep, let's go ahead and connect. give a proper server name. Okay, while this thing logs me in, I can go to SQL databases and I can create as many databases as I want, and I can select the server name, and all of those databases should be available in my data factory. Sorry, in my data studio. Server name. Uh, oh, not that server name. Wait a second. This is the actual server name. Yeah, company name. There you go. So as long as I select this as my server name, all the databases that I create will be connected to this particular server. Right now I've got only one database connected to my server, company name employee DB. Let's go there. If I go into databases, there you go, company name employee DB. In system databases you will find a master database which we are not going to ever use, honestly. uh, Actually we do use it sometimes whenever you want to do any kind of operations related to the whole database, metadata of the database, or gathering information about what are the different DBs exist. All those kind of things can be done with the help of master database. Okay, let's write a new query here. Let's see, do we have any tables? Obviously there shouldn't be any. There you go, it's empty. If I come here, select the whole thing, paste the whole thing, I want to run this part. It's done. Now since I've selected only this should have been executed, and only one table should appear here. If I refresh, there you go, I've got one table created here. Now I didn't create a schema yet, so let's go ahead and do that. Schemas. By the way, here you can see DBO is a schema that already exists. Script as create. So when I go into the advanced concept, that's when I'm going to explain users and roles. So these are two different things which are very much essential to create uh, and give access to users, and control and manage who has access to what different commands. Okay, SQL schema DBO. Instead of DBO, I'm going to create SLS. Let's go. Yeah, that has been created. I don't know to save this query. Okay, command completed successfully. Total execution time is this. Let's create both of these tables as well. This. Let's create a view. Done. Coming to the parameterized view, sorry, stored procedure, that is also done. Okay, Now let's execute store procedure with some values. Now to execute it, I'll simply use exec. I'll have to give a first name. I'll give my name here. Let me fill in all of these details and get back. Or actually, let's just copy paste them. First name, last name, email, department, hiring date. Uh, do I have to give a date time now? Okay, I'm just going to skip this part for now. But yeah, that's basically how you insert data. Sorry, that's basically how you run a stored procedure. Okay, now when you want to create a unique identifier, you'll simply say, instead of int, you'll simply say unique identifier, and then you can run this and your table is going to be created automatically. But if you have an existing table and you want to take data uh, that you already have and modify that table, then you can go ahead and use the design option from Azure Data Studio. Let's get into designer. Oh, by the way, if I refresh, there you go. There you go. There you go. Designer takes a bit of time because once you load it, there are so many different things that you can do from the designer. But as a developer, it's never recommended to use the designer. It's always recommended to write the query. But for this tutorial sake, I'm just going to use the designer to do couple of changes. Okay, now this is my primary key, and by default primary key will never allow any null values. I'll change the data type into unique identifier, and for hire date do not allow any null values, and for the default value uh, get date. Yep, that's right. So I'll simply use the get date function. So this will automatically take the present moment date and will fill it in this directly. Okay, these are the two different changes that I want to do. Control S. Okay, I'll have to modify the data type in all the different tables, all the related tables first, and only then come back here. But you know what, actually I can write a query to do the same, to do that part. Okay, let's go here. Employee ID is the column name that I want to change. Unique identifier. This is going to throw an error, right? Okay, first let's change it here. Okay, so that's how you can change the unique identifier. And so whenever you are inserting any data into this table, automatically a GUID value is going to pop up in this column, and the current date is going to be entered into the hire date column. And here you can see the script for this. What I'm going to do is I'll take a new query. Let me connect to the appropriate database. Come on. I should have just done this. You see how quick that is. I'll say employee DB new. Okay, let's run this. Table has been created. Now let's use an insert statement. Yep, that's the thing. I forgot to add the default function that I have to use. So after adding this, whenever I insert any data, this is automatically going to take uh, generate a new ID by default, and then it will use that. There you go, one row affected. Now if I do a select star, here you can see the proper grid has been implemented. Now it automatically generated this grid for me. Okay, so this is a grid that I have passed just for tutorial purpose. So let's say if you have got 20 different records here, and if you have the manager in the first record, then all the 19 records will have the first records employee ID as the reporting manager ID. So just this is just for example sake, but yeah, here you can understand that this has been populated automatically, and also the hire date has been populated automatically. This is also in a date time format. You can see here hire date is date. Okay, so those are some of the most important concepts of SQL database and data modeling in general. Uh, I hope you guys have learned a couple of things and enjoyed going through this whole process. And if you have really made it 1 hour into this video, really appreciate you guys. Thank you for watching.